Mikaela Shiffrin has done it again. 12 years after winning her first Olympic slalom gold, she has returned to the very top of the podium, proving once more that she is not only one of the greatest athletes in ski racing history, but possibly the greatest slalom skier of all time. Her success is not just about talent or experience. It is about physics, biomechanics, precision, and an unmatched ability to turn snow, gravity, and timing into pure speed. Today, we are going to explore the science behind Shiffrin's dominance, and uncover what truly makes her so fast, so efficient, and so unstoppable. How remarkable is Shiffrin's Olympic slalom comeback? It is extraordinary because alpine skiing is one of the most unforgiving sports in the world. Winning Olympic gold requires perfection over a run decided by hundredths of a second. Shiffrin's ability to return after more than a decade and still outperform the world's best shows not only longevity, but an unmatched technical mastery. Why is Mikaela Shiffrin considered the greatest slalom skier ever? She is considered the slalom GOAT because of her consistency, record-breaking victories, and the fact that her technique remains the most efficient in the sport. She combines aggressive speed with extraordinary control, making fewer mistakes than anyone else over the most demanding courses. What makes slalom skiing so difficult compared to other ski events? Slalom is the most technical alpine discipline. Racers must navigate tightly spaced gates with rapid turns, extreme edge angles, and constant transitions. The skier has almost no time to recover from errors, which makes precision and rhythm absolutely essential. What is the role of edge angle in Shiffrin's skiing? Edge angle is one of the most important factors in slalom speed. The sharper the ski is tilted onto its edge, the more it carves into the snow instead of sliding. Shiffrin consistently achieves extreme edge angles while maintaining balance, allowing her to grip the snow with maximum efficiency. Why does carving matter more than skidding? Carving creates a clean arc through the turn and minimizes friction. Skidding causes sideways sliding, which wastes energy and slows the skier down. Shiffrin's skis cut through the snow like blades, meaning she loses less speed during every turn. How does Shiffrin manage pressure during a turn? She applies pressure with perfect timing. At the start of the turn, she builds force gradually. At the apex, she reaches maximum pressure for grip and acceleration. Then she releases instantly for the transition. This constant adjustment keeps her skis locked into the snow while maintaining speed. What is the sweet spot in a slalom turn? The sweet spot is the precise moment when edge angle and pressure combine at their peak. At this point, the ski bends deeply, storing energy like a spring. When Shiffrin exits the turn, that stored energy releases forward, creating acceleration rather than slowdown. How does Shiffrin choose the optimal line through the gates? Her line is incredibly direct. She takes the shortest and most efficient path possible without losing control. Every extra centimeter traveled adds time, so her ability to stay tight and clean around gates is one of her greatest advantages. Why is trajectory as important as speed in slalom? Speed alone is meaningless if the skier takes a longer path. Slalom racing is about minimizing distance while maximizing flow. Shiffrin's trajectory is a perfect balance of directness and rhythm, allowing her to remain fast without overturning. What does pendulum motion mean in skiing? A skier's body moves like a pendulum between turns. If the swing is too wide, transitions become slow. If it is too stiff, rhythm breaks down. Shiffrin controls this pendulum motion perfectly, keeping her center of mass moving smoothly downhill while her skis carve side to side. How does Shiffrin maintain rhythm and timing so well? Her timing is almost predictive. She is not reacting gate by gate, she is anticipating the next turn before finishing the current one. This creates a seamless flow, making her runs look effortless while remaining extremely fast. What role does core strength play in her dominance? Her core is the foundation of her stability. A strong core keeps her upper body quiet and controlled, allowing her legs to move rapidly underneath. This reduces wasted motion and ensures that energy goes directly into speed instead of correction. How do her ankles and knees contribute to her precision? Her lower body articulation is elite. Ankles fine-tune edge engagement, knees absorb terrain shocks, and hips drive force into the turn. These micro-adjustments allow her to maintain grip and control even on uneven snow. Why is muscle elasticity important in slalom skiing? Slalom requires repeated explosive contractions in rapid succession. Shiffrin's muscles have exceptional elasticity, allowing her to load energy in turns and release it instantly. This helps her sustain power and speed from start to finish. How does sports science confirm Shiffrin's technical superiority? Modern telemetry uses GPS mapping, force sensors, and motion analysis to measure performance. Data consistently shows that Shiffrin loses less speed in transitions than her rivals, proving that her efficiency is not just visual, but scientifically measurable. Why does Shiffrin accelerate out of turns instead of slowing down? Most skiers lose speed during turns because of friction and skidding. Shiffrin's perfect edge grip, pressure timing, and ski rebound allow her to turn turns into acceleration points, giving her an advantage at every gate. How might Shiffrin influence the next generation of racers? Her technique is already becoming the model for future athletes. Young racers will study her pressure control, carving efficiency, and data-driven precision. Shiffrin is not only winning, she is reshaping what slalom skiing looks like at the highest level. What is the ultimate secret behind her record-breaking speed? There is no single secret. Shiffrin's greatness comes from the sum of all parts: physics, biomechanics, timing, mental focus, and flawless execution. She is the perfect example of science and athletic artistry combined. Finally, Mikaela Shiffrin's return to Olympic slalom gold is more than a victory. It is the continuation of one of the greatest technical careers in sports history. Her dominance is not based on luck or brute force, but on precision, efficiency, and a deep mastery of the science of skiing. She is not just racing against competitors. She is racing against the limits of physics itself. If you enjoyed this deep dive into the science behind Shiffrin's legendary comeback, don't forget to like, share, and subscribe for more educational sports stories and powerful athletic breakdowns. Thank you.